Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for removing duplicate elements from a sorted linked list. Let's look at the problem description. We are given the head of a sorted linked list and we have to delete all the nodes that have duplicate numbers. And we need to leave only the distinct numbers from the original list, and we have to return that linked list sorted as well. Let's take a look at the example one. So this linked list has 1, 2, 3, 3, 4, 4, 5. So in this node 3 and 4 have a duplicate. So we have to remove all nodes which has value 3 and 4. The remaining list will contain 1, 2 and 5. So in the example 2, this linked list has 5 elements and the node 1 has duplicates. So we have to remove all the nodes which has value 1. After removing, so the linked list will have only 2 and 3. The constraints for this problem are the number of nodes in the linked list is ranging from 0 to 300 and the value of each node is ranging from -100 to 100. So the list is guaranteed to be sorted in ascending order. Let's look at the approach to solve this problem. So we are given the head of the linked list which has 7 elements 1, 2, 3, 3, 4, 4, 5. After removing the duplicates 3 and 4, the returned linked list will have 1, 2, 5 in ascending order. We can solve this problem by traversing this linked list from head to tail. As we traverse, we need to keep track of the previous node and the next node. Whenever we process a node, we check whether the next node from that current node is having the same value. If that is the case, then we'll have to find the next unique node. For example, when we process this node, we check the next node has 3, which is duplicates. Here we have to find the next unique node, that is 4. We locate the node which has the unique value. We keep track of the previous node. So we have the pointer to the previous node of 3. So once we locate the unique node, we can link the previous node's next pointer to point to that unique node 4 here. So these two nodes will be removed from the linked list. So basically, as we traverse, we keep track of the previous node and the next node. Whenever we see the value of the current node is equal to the value of the next node, then we need to find the next unique node in that linked list from the current node and then link the previous and the unique node together. So for example, here when we process this node as a current node, the previous node points to 2, and then from when we process here, we locate the next unique node which is 4. So then we link 2 and 4. So that is what I have written here. Traverse the linked list. If the value of the current node and the next node are equal, find the unique node from the current node. If the previous node is null, then update the head. And then if the previous node is not equal to null, then link that previous node and the unique node. Then set the unique node as the next node to be processed. If the value of the current node and the next node are not equal, then we set the current node as the previous node before leaving the current iteration. We repeat this until we visit all the elements in the linked list. Let's look at the flowchart. Input for this procedure is head of the sorted linked list. First we initialize the previous node, current node and the next node to null. The current node will be initialized with the head of the linked list. Okay. Then we start traversing the linked list in this for loop. If the current node is equal to null, then we return. Otherwise, we remember the next node of the current node in the next node variable. Okay. Then we check if the next node is not equal to null and the next node value is equal to the current node's value. If they are not equal, then we simply update the previous node variable with the current node. If they are equal, then we call the get next unique node function to get the unique node from the current node and then assign that return value to the unique node variable. Then we check whether the previous node is equal to null. So this is for the case where the duplicate nodes are present at the head of the linked list itself. Okay. So if the previous node is equal to null, then we simply assign the unique node as the head of the linked list. Otherwise, we link the previous node to the unique node. Okay, update the previous node's next pointer to point to the unique node. Then we assign the unique node as the next node. And after processing the current node, then we update the current node pointer by assigning the next node value so that the next node in the linked list will be processed. So we repeat this until all the elements are processed. Then finally we return the head of the linked list. Let's move on to coding. First I initialize the previous node, current node and the next node pointers. Next I initialize the current node to point to the head of the linked list. Then I write the for loop to traverse the linked list. First I update the next node pointer with the address of the next node. Then I check whether the next node is not equal to null and the value of the next node and the current node are equal. If this is true, then I call the get next unique node function to locate the next node which is not equal to the value of the current node. Next I check whether the previous node is equal to null. That means the duplicates are present from the head itself. So I update the head pointer with the value of the unique nodes pointer. Otherwise, I link the previous node with the unique node. So I update the previous node's next pointer to point to the unique node. Then I make the unique node as the next node to be processed. So I update the next node with unique node pointer. So if the values are not equal, then I update the previous node pointer's value with the current node's pointer. Then finally I advance the current node pointer to point to the next node so that the next iteration process the next node. Finally I return the head of the linked list. Next I'm going to write the get next unique node function. First I declare the node pointer which is initialized with the current node pointer. Basically I traverse the linked list from the current node and try to find the node which is not equal to the current node's value. So in each iteration I compare the node's value with the current node's value. If it is not equal, then I return the node. Update the node pointer. So if none of the nodes are unique, the rest of the linked list, then finally I return null. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given the head of the linked list which is in sorted order and it has 7 elements. So in this node 1 have duplicates and node 4 have duplicates. After removing the nodes with those values, we will have the linked list with value 2, 3 and 5. Okay. So first we initialize the previous node, current node and the next node pointers. So the previous node and the next node and the current node will be set to null. And then the head is pointing to the first node 1. Then we are initializing the current node to point to the head of the linked list, and we enter the for loop. So when we enter the for loop, the previous node is null, the current node points to the head of the linked list, the next node points to the second node in the linked list, and the head points to the node 1, and the unique node is null. Okay. First we check whether the next node is not equal to null. In this case it is true, it is not null, and the value of the current node and the next node are same. So in this case both are same, so this condition is true. So we go ahead and try to find the next unique node. So in this case, from here, the node which with value that is not equal to 1 is this node. So this function returns a pointer to this node. Okay, so once we locate this node, we check whether the previous node is null. If that is true, that means the duplicate nodes are present from the head itself. So we have to advance the head. So that's what we are doing. So we are assigning the unique node as the head. So the head will be pointing to node 2. So we remove these two nodes from the linked list. Then we update the next node pointer to point to the unique node. So the next node will be point to 2. So that's why when we leave this iteration 0, the next node points to 2, and the head points to this node 2, and the unique node is pointing to this. Okay. And in the iteration 1, we process this node, and we initialize the next node that points to node 3, and both the nodes are not equal. So we go to the else part and we simply update the previous node with the current node's value. Okay, so that's why the previous node becomes 2 from null. Okay, and then the current node will become 3. Okay, so that the next iteration process this node, and the head is still 2, and in the iteration 2 we process node 3 and we check with the value of the next node. They are not equal, so we simply update the previous node with the current node value. So that's why the previous node becomes 3 from 2. Okay, and then we update the current node with the pointer pointed by the next node. So in the next iteration we process the node 4. So in the iteration 3, the current node is 4, and here the current node's value and the next node value are equal. So we call the get next unique node function, which returns a pointer to this node. Okay, and we check the previous node is equal to null. In this case it is not, because previous node pointing to 3. So we update the next pointer of the previous node to point to the unique node. So basically we establish the link between 3 and 5. Essentially we remove these two nodes. After updating the link, we update the next node to point to the unique node. So the unique node will be assigned to the next node, and before we leave this iteration we update the current node to point to the next node, so that the 5 will be processed in the next iteration. So that's why the next node is 5, the current node is set to 5, and the iteration 4, the current node is pointing to node 5, and the next node is null, and the previous node is 3. So because the next node is null, update the previous node with the current node pointer. Okay, and then we update the current node pointer to point to the next node. In this case the next node is null. So because it is null, this condition is false, so we break out of the loop, and finally we have 2, 3, 5 in the linked list. So that is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Time complexity for this procedure is order of n. For this case, the linked list has 7 elements. In order to remove the duplicates in this linked list, we have to traverse all the nodes in the linked list. Okay, so this for loop performs 5 iterations. So for example, 1, 2, and this is 3, and this is 4 and 5, because we call the get unique next unique node function and advance the pointer to the unique node. So we skip few iterations because whenever there is a duplicate. So if there are n elements in the linked list, the for loop performs n minus number of duplicates iterations. Okay. In the worst case, if all the elements are unique, then we ended up traversing all the n elements. So that's why the time complexity is order of n. Space complexity is order of 1 because we are not allocating any additional space. So we use these 3 pointers to process the linked list. So the space complexity is order of 1. Thanks for watching this video. Have a great day.